We have seen what a slider crank is. It is essentially 4 links connected using 3 revolute pairs and a sliding or prismatic pair. Now we are going to change its fixed link. So instead of fixing link 1, we'll be fixing link 2 like this. In its essential form, this inversion of slider crank looks like this. Link AB is fixed, so this is link AB fixed, and BC will be used as the input. So this link BC will be used as the input and we'll be moving this. Right now we are also seeing some traces of points. We'll talk about that in a moment. So this inversion can be made a little more useful by adding a couple of extra links. Here they are. So we are going to extend this link AC like this, add one extra link over here, and at the end of it we will attach a tool which is constrained to reciprocate along this line. So as our input link BC rotates, the tool reciprocates back and forth. Now let us see its extreme positions. So the tool is in the rightmost extreme when our input link BC is over here. Then we will retract it back, so it will go towards its leftmost position over here when BC is in this position, and then again it will move forward. So it retracts and moves forward. But if you notice the angle through which our input link is turning when moving forward and when retracting the tool back, these two angles are not equal, and therefore the tool will take more time to go forward, and in a shorter time it will be retracted back. Such mechanism is called a quick return mechanism because it retracts back in a shorter period of time. And this is just as well, because when the tool is moving forward, it is doing something useful, while getting backward, it is just getting ready for the next stroke. So we don't want to waste our time there. So such mechanisms are commonly used in machine tools, where tool does something useful in a cycle and then rest of the cycle is finished quickly, where the tool is just brought back to the initial position. This quick return characteristic of a mechanism can be quantified using a ratio called as the quick return ratio. It is a ratio of angle turned by the crank during the forward stroke of the tool divided by the angle turned by the crank for the return stroke of the tool. And since the crank is usually connected to an electric motor, these angles directly translate into the time taken for forward and the return stroke. So the ratio of these two angles is the ratio of these two time slices within which the tool is moved forward and then brought back. So that is quick return ratio. The mechanism that we saw here is called the Whitworth quick return mechanism, and it is derived from the second inversion of slider crank.